This is Beyond the Business.
When people hear energy markets, they often imagine traders, prices, charts, and headlines. But energy markets are not just finance. They are part of the system that decides what energy really costs before it even reaches you. Not the technical cost and not the production cost. The system cost, the cost of risk, of timing, and of stability. Because energy is not sold like a normal product. If you buy a phone, you can wait. If you buy a car, you can compare options. But energy is different. You don't negotiate it, you don't pause it, and you don't order it later. It has to be there, instantly, at scale, and every day. And that changes everything. So when we talk about prices, we are not talking about one simple number. We are talking about a whole architecture that sits between production and reality. A market that doesn't just reflect supply and demand, but also controls behavior, protects the system, and sometimes creates its own problems. Today, I want to look at energy markets the way we look at the product. In the normal sense, a market is simple. It's a space where something is bought and sold, a product, a service, a resource. You trade value, you trade access, and you trade availability. But the energy market does not work like that anymore. Because today we are not really trading energy, we are trading permission. Permission to produce it, permission to burn it, and permission to keep the system running the way it was built. That's why energy pricing is no longer only about supply and demand. It's also about emissions, about limits, about waste, about what the system is allowed to push out into the world and what it is forced to pay for. And once you see it through that lens, the energy market stops looking like a market for the few. It starts looking like a market for consequences. Let's take a look at the sellers. They know exactly what they are selling. Not only energy, not only a service, not only supply. They are selling something that already carries emissions inside it. Because long before the product reaches the market, the system has already burned fuel, spent electricity, moved materials, maintained infrastructure, and created waste along the way. For the seller, this is not a surprise. It's a built in cost of doing business, it's part of the process and part of the design. But for the buyer, it's different. The buyer thinks they're purchasing a simple thing, a liter of fuel, a kilowatt per hour, a delivery, a warm house, a working factory, a normal life. They rarely see what was consumed to make that outcome possible. They don't see the upstream energy burned to extract, refine, store, and deliver it. They don't see what the system had to keep running in the background just to make availability feel normal. So, what gets traded in energy markets is not just a product or a service. It's an exchange where the economic value is obvious, but the environmental cost is hidden by default. Money moves instantly, the service works, the product delivers value. But the emissions and the waste don't disappear, they simply stay attached to the system as a silent second layer, already locked in before the buyer even makes a choice. That's where the imbalance starts. In economic terms, it's a useful product. In environmental terms, it's a future cost. So the real question is not how much does energy cost. The real question is where is the balance when value is priced upfront, but damage is priced later. And this is where the whole system becomes unbalanced. Because the market only recognizes one thing, the deal. You pay, you receive, transaction closed. But the impact doesn't close within transaction. The footprint stays in the system and it stays in the environment and it stays inside society. So what you get is a strange split. Economically, the exchange looks successful. Value is created, energy moves, industry runs, people live normally. But environmentally, the exchange is already negative because the product comes with costs that are not part of the deal, they are part of reality. And that's why energy markets have this built in contradiction. They are designed to distribute supply, to optimize price, to keep the system liquid, but they are not designed to carry consequences. So the system keeps doing what markets do best. It pushes everything that doesn't fit into the price outside the price. That's how the gap appears. You have an economic model that rewards movement speed, volume, and stability. And at the same time, you have an environmental model where every successful trade means more load added to the background. And the dangerous part is that both sides can be true at the same time. The market can work perfectly and the system can still deteriorate. So the real question becomes very simple. If we keep treating energy like just another commodity, who exactly is carrying the cost that does not show up in the contract? Because that cost doesn't disappear, it just moves. And sooner or later, it ends up in the only place where it can be paid. Not by the seller or not by the trader, not even by the market itself. It will be paid by society. It works same like cigarettes. There are sellers and there are buyers, and both sides understand what the product is. Everyone knows smoking is harmful. It's proven, it's not debate. So what did public systems do? They restricted smoking in public spaces. They introduced bans. They increased taxes and excise duties. And yes, it changed behavior around the edges. But the market did not disappear. The product stayed. Demand stayed. Many people did not quit. They adapted. And this is exactly what happens with energy. We all know the fuel system comes with emissions. We all know there are side effects. Even clean energy has its footprint. But we still use it because the system is built around it. So we keep repeating the same pattern. We introduce restrictions, we add taxes, we try alternatives, but the problem doesn't go away, it just changes form. Now imagine this. You walk into a store, you buy a product, you take it home, and it works perfectly. But every time you use it, it leaves a mess behind. Not a small mess, a real one. Damage, smoke, waste, repair costs. So what do? You don't sit there and say, well, that's just how product work. You bring it back, you ask for replacement, you ask for compensation, you ask why the producer is allowed to sell it in the first place. Because in a normal market, the product is not judged only by whether it works. It's judged by what it does after you use it. And that's the part energy markets ignore. Energy is sold as a working product, but structurally it behaves like a defective product. Because the footprint is not an accident. It's built in every time. And the biggest illusion is that this defect is treated as acceptable. Not because it's invisible, but because nobody knows where to return it. There is no counter, no receipt, no refund policy. So the consequences don't go back to the seller, they go forward into the system. Into the air, infrastructure stress, insurance costs, public budgets, higher bills. That's the real design of today's energy market. The product works, but the damage is offloaded. That's why the market looks efficient on the paper, while the real cost keeps showing up somewhere else. If we follow this logic all the way, the next step becomes obvious. In a normal market, if a product is defective, the seller doesn't get to walk away and say, "That's not my problem anymore." The seller compensates, either through a refund, a replacement, or repair. So, if energy comes with a built in damage, then the seller should carry built in compensation. Not later, not as a moral discussion, not as "we will fix it one day." Upfront, inside the deal. And if we translate that into the language of markets, then the compensation has to be priced in at the moment of sale. Meaning this, every unit of energy sold should carry a defined cost for what it leaves behind. 1 ton of fuel, 1 kilo of coal, one battery pack, one industrial energy contract. Whatever the product is, the system should estimate the future damage it creates and attach that number directly to the seller. Not as a vague pledge, as a real obligation, and that obligation can be handled in two ways. Either the seller pays it into a regulated compensation pool that is locked for environmental repair and long term recovery, not for politics and budgets. Or the market forces the cost directly into the price, and the buyer sees the real bill, not the convenient one. Because right now the market works backwards. The seller sells the benefit, society pays for the side effects, and the damage remains unpaid until it becomes an emergency. That is not a market failure, that's market design choice. Now we get to the next part of any market: location. Because energy is not sold in one global marketplace, it lives inside infrastructure, borders, grids, and local rules. And that changes everything. In theory, energy markets are just sellers and buyers. In reality, what matters is whether you actually have a choice. In some places, energy works like a real market. There are multiple suppliers, different contracts, competition, switching options. Even green energy becomes a product you can select, like an upgrade. But in many places, there is no market. There is one grid, one system, one pricing logic. Sometimes it's a monopoly, sometimes it's a regulation, sometimes it's both at the same time. And the customer doesn't really choose, the customer just connects. That's the difference people miss. Energy is not like a normal product. If you don't like the price of a phone, you can delay the purchase. If you don't like a service, you can cancel it. With energy, you don't have that option. You can't pause heating, electricity, the economy itself. So location becomes power. The more limited the choice, the more the market shifts from trade to dependency. And once that happens, pricing stops being a negotiation. It becomes a condition of living inside the system. The same unit of energy doesn't change when it crosses a border. Oil doesn't become different oil, gas doesn't become better gas. Electricity doesn't become cleaner electricity just because a different country prints a different bill. But the price changes anyway, sometimes slightly, sometimes by multiples. And that difference is not explained by the product, it is explained by what the system attaches to it. Because what people call energy pricing is not only a price for fuel or power, it is a price for everything that comes with it: storage capacity, standby readiness, backup infrastructure, grid, supply risk, seasonal pressure. So the blind spot is not the energy is expensive. The blind spot is that the same energy can be sold at two different prices depending on where the system decides to park the hidden costs. In one place, the bill looks low because the system carries the burden elsewhere through state guarantees, delayed maintenance, or public absorption. The customer feels relief today, but the cost still exists. It just moves out of sight. In another place, the bill looks high because the system loads the full structure into the price: resilience margins, risk premiums, redundancy. And here's what makes it important: the footprint is the same, the waste is the same, the long term consequences are still there. What changes is only the accounting route. So, energy markets are not only a marketplace for energy, they are marketplace for consequence allocation. They decide who pays upfront, who pays later, and who never pays at all because the cost gets exported into someone else's system. That is why energy markets don't just follow supply and demand, they also follow power leverage and architecture. Because the biggest pricing mechanism in energy is not the fuel itself, it's the ability to shift the bill. So, why does nothing really change? Because the market model was never built to deal with the consequences, it was built to handle transactions. For decades that worked, the system could sell the product, take the money, and push the footprint outside the deal, outside the price, and outside the contract. But now the conditions are changing, not because someone decided to change them, because volatility is already inside the system. And once volatility becomes structural, the market stops being a price mechanism. It becomes a survival mechanism. So the real choice is simple. Either we update the rules of the market to include the consequences, or we keep trading the same product the same way, while the operational reality keeps getting more expensive. That's how systems lose control. So we don't pay once, we pay for the benefit today, and we pay again for the damage tomorrow.